In the previous video, we talked about a composition of functions. So given two functions, or even 3 or 4 or 5 functions, as many as you can have, but we're only going to look at 2 of them. So given two functions, and you can join them together by 2 steps. So you can first plug a number into the first function, and then when you get output, you put it into the second function. But you can switch the order. You can put it into the second function and into the first function. So we also looked at the 2 examples. This is the fractional example. So now we're going to look at a different example. We can do a square root example. So in this one, we have f of x as square root of x plus 4. And g of x, we can do 3x minus 2. So the first function is a square root function. The second is a linear function. And then we want to do these 4 questions. So first, let's start with f and g of -1. And we're going to do 2 steps. First, we're going to plug -1 into the g function. So this one is the g function. And for the letter f, we're going to keep it. We're just not going to, we're going to do the f function in the second step. So when we plug -1 into the function, we replace x with -1. So we have 3 times -1. If you can do this in your head, you can go ahead and work out in your head and write down the answer. So we're going to have -3 minus 2, that's a -5. Now we're going to do second step. So this is our step 1, and this is still step 1, That's the answer from step 1. Now we're going to plug -5. Now we're ready to do f of -5. So that means you plug -5 into the f function. That's our step 2, the second function now. So in the second function, we replace x with -5. And notice after we simplify it, we are going to get square root of -1. And again, we only talk about real numbers. We're not talking about imaginary numbers. You're not going to get I, so you would just have to say undefined or no solution. Because for square root functions, you cannot have a negative number with the square root. Now let's, so pretty much undefined was so no answer for the first question. Let's do the second question. So for some, when you have a square root function or division function, possibly you could have no answer. But if you don't have division or you don't have square root, you will always get an answer. So let's look at the second part. We are supposed to plug 0 into f function. We keep g. So this is our step 1 we're doing. If you don't like this way of writing, separate them into 2 steps. So first you do g of -1. When you get an answer, you do step 2, plug the number like -5 into f function. So now we're gonna work out f of 0, which means in f function we replace x with 0. And to simplify this, we're going to get square root of 4. Square root of 4 is 2. And now let's do step 2. We replace x with the 2 in g function. So we replace that x there with 2, and we get the answer, final answer of 4. Okay, now let's work out the next 2 problems. What if we don't have a number to plug in? We just have a variable x. All right, so let's see. Number 3, f and g of x. So we're going to still follow the same steps. So do step 1, find f of x. And we don't really have anything to do. When you have a specific number, you do have to replace, in g function, replace that x with the number given. But we're just having the letter x. So it's going to be exactly the same. You just have to copy that from what we have. So we're going to have f of 3x minus 2. So 3x minus 2 is equal to g of x as given. Now that's first step. Second step is the tricky one, because in this step we're going to have to replace, we're going to plug 3x minus 2 into f function. So this is our f function. And when you remember, this x is different from 3x minus 2. So you're going to have to, when you see x, whenever you see x in the function, you're going to replace that with the whole thing, 3x minus 2. So we're going to get, we keep a square root. When I see x, I'm going to replace it with a new thing, 3x minus 2. And there's a plus 4, I copy it. So 3x minus 2 is what's given, what we have, output of g, and we're going to replace the x. And we can simplify this a little bit. Negative 2 plus 4 is positive 2. So that would be the final answer for f. So as you can see, after you put these two functions together, we got a square root of 3x plus 2. And now let's look at the other one. What if we switch them? Step 1, we're going to find what f of x is, which we can just copy the answer from here. That's f of x. So this whole thing right here can be replaced by square root of x plus 4. We keep g because we haven't worked on g yet. We just worked on f of x. And next step, we're going to work on the g function. In the g function, we suppose, so this x corresponds to a new x, square root of x plus 4. And we're going to replace the x, the letter x, with the square root of x plus 4. So we will get 3 times square root of x plus 4, and then minus 2. And notice that there's nothing we can do because we cannot really simplify this any further because this minus 2 is not within the radical sign. We cannot combine them. Previously, we were able to combine them because both of them are within the radical sign. That's why it's very important to write clearly how long your line is. And this one stops right here. So this minus 2 cannot be combined with that plus 4. So that would be the final answer. There's nothing we can do here. X plus 4 cannot be combined. Square root cannot be simplified. 3 times this cannot be simplified, and minus 2 we can't either. So this is the final answer. We can take a look at these two answers. So this one is our composite function for f and g, but this one is the composite function for g and f. And in calculus, we do use this a lot. Because really in most of functions you will see will be a composite function of 2 or 3, even more functions. And so a lot of rules, like when you do derivatives, antiderivatives, especially derivatives, you have to know which two functions we have, basic functions, in order to use those rules.